Hello. Today I will be talking about my lab 5, which is yo-yo projectile. The purpose of this lab is to use Tracker and GlowScript to create a side-by-side computational versus experimental comparison of a yo-yo projectile. The setup of this lab is includes a person about to fling the yo-yo from a string. The yo-yo at the instant before launch is set to be the center of axis. The yo-yo is launched in the air to the left of the axis. A person is holding a roller on the side to get the measurement units in the video for the tracker, as you can see in the picture here. Equations used. The main equations are the momentum update and the velocity update formulas. Newton's second law are used to update the velocity and position of the yo-yo as well as the drag to accurately represent the physical properties of the yo-yo during the projectile motion in the GlowScript code. Creating the computational model. So here I have some GlowScript code. To create the computational model to match the experiment, I have carefully chosen the starting position and velocity along with the drag force and the net force using formula taught in class. The drag force along with gravity creates the computational model shown in the next slide. So here we have the results of the computational model. After plugging in all the values described earlier, we got back our position versus time graph for the model in the experiment. We can compare our tracker analysis with our model. We can see that it fits very well. However, the model is still a little bit off. This could be due to the way that the camera is recorded. Since the recording is done in a kind of a side view, it messes with the axis a little bit. The red one is the tracker code, and the green line here is the computational model. And then we have our first question. What does it mean? So how did the string affect the experiment with the yo-yo? For our experiment, although the force from the string does exist, we measured our experiment starting from a point after the force from the string has already been applied. This changed our initial velocity, but it does not change anything during the motion of the projectile. We can see in our previous slide that the initial velocity of the ball is negative 1450 for the GlowScript code. This is taking into account the force applied by the string at the very beginning. And the force does not affect the yo-yo after the initial velocity because it doesn't change anything in the motion of the projectile. Question 2, what if? What if the yo-yo was thrown in a steeper angle? How would we modify this in our computational model? In order to create a steeper projectile motion in our computational model, we would have to make our initial velocity bigger, thus creating a bigger slope and a steeper projectile motion. And this concludes my presentation over lab 5, the yo-yo projectile. Thank you for watching.